Today we are going to study about magnetic forces and magnetic fields. And when we are talking about magnetic forces, magnetism, the first thing we need to understand is magnetic fields. So now what is a magnetic field? Now suppose that you have a magnet which has it's a permanent magnet, a ferromagnetic material which has a north and a south pole. So around it there is a field which is called a magnetic field. Now suppose, how do we know there is a field near it? Now I have another magnet here which has also a north and a south pole. So let me just bring this magnet to this magnet, the other one, so it gets attracted to this magnet. Okay, let's see it again. So it means that there is something near around these magnets, due to which when the other magnet comes near them, it gets attracted towards the other magnet. So this field around a magnet is called a magnetic field. So we don't know if there is no other magnet or an iron object near this. We don't know if there is a field or not. But as soon as you bring another magnet near this, you can experience that there is a force around, there's a field around these magnets. Okay. Now the first thing is how these magnetic field lines they look like. So in order to check that, let me just do a small experiment. Maybe I'll take this magnet and I'll keep it under this paper. Okay. And let me just sprinkle a little bit of iron O-rings over this magnet. So under the paper I have put the magnet, and over it I am putting some iron filings. So if you can see that these iron filings, they are getting oriented in particular directions. Let me take some more of iron filings and see if it works better. So let me just put some more iron filings. Okay. So if you see minutely, there is a pattern of these magnetic field lines. The magnetic field lines are going out from here, and also they are going out from this direction, and here they are moving from one terminal, one pole of the magnet to the other. So this is not in one dimension, it is in 3 dimensions. You can see these iron filings, they are also pointing upwards. So it means that there will also be a magnetic field in this direction. Now how do we know which is north pole and which is south pole? So we have a compass needle here. So the red one is north and this is south. So if I bring it, it means that this is south. So it means this pole is north. Okay. And it means that red one is coming near. So this is north and this is south. So from compass needle you can also know about these magnetic field lines, which will be from north to the south pole of the magnet. But this magnet is not a very good magnet, because these magnetic field lines, they are coming from here and they are ending somewhere here. Instead it should have been start from here and go to this terminal, and start from here and go to this pole. Okay. So but it just gives you an idea of how magnetic field lines they will be. Now let me say that if I move this, then you see this 3-dimensional effect. I don't know if it is visible or not. You can see that the magnetic iron ore rings, they are behaving in accordance with the magnet. Now let us see how the magnetic field will be with this magnet. There is a north pole and a south pole. So let me just keep it under the paper and then put iron filings over it and see how it behaves. Okay. Okay, so if you see this pattern, you see that these magnetic field lines here are from one pole to the other. Now this is a good pattern actually, so it should have been towards this side. You see that you have these magnetic field lines like this, okay, and here they're going outward from these poles, and if I put iron filings here also, they will just come back. So all these lines that they're coming from here, they will come back to this pole. Okay, and here it's a complicated magnetic field lines, because this horseshoe magnet is not completely I mean the north and south poles, they are not completely aloof. It seems that there's some pole segregation here also. So you have magnetic field lines like this, and here it is a little bit complicated. It's a merging of magnetic field lines due to various parts of the magnet. But you see this side of the magnet this is how it should look like, that the magnetic field lines, they are from north to south, and it's going outward from here, and you can find out which is north and which is south. So the white one is for the south, so it means this is north pole, and it means that this is south pole. Okay, so you can check the poles by using a compass needle. So it means that if I have to draw this pattern, it means that it should look something like this. That if you have a magnet north and south, the magnetic field lines will be from north to south. Okay, so you see that if we move from the north pole, so it will be a perpendicular and then parallel and then towards this side. So the magnetic field lines are starting at one point and they are ending at the other. Okay, so there will be magnetic field lines which will be like this, and inside they will be from north to south and they will be parallel to each other. Okay, so the magnetic field is depicted by a symbol B vector, and it has a unit of Tesla, and it's written by T, and there's another unit which is given by Gauss. So 1 Gauss is 10 to the power minus 4 Tesla.